Hi, I'm Remi De Meyer, and I was on-site manager for Murray & Dixon, so I managed all the construction activities on the Plaatje Kimberley University project. And I must say it was quite a challenging project, and having all these challenges, it developed me as a person a lot, but as well, we developed as a team together. It's a floating concrete facade as such, and the facade is, structural steel is an intricate part of the structure, so without the steel, the structure can't function. So those two elements are key. The main envelope of the structure is a concrete shell, which is then supported via braces from the slab to the wall. And those braces basically prevent the walls from bowing. So the walls are very slender, they're about 220 millimeters thick. So without the structural steel elements, the whole of the building would be impossible. Then there's elements like the lift shaft, which provides stability to all these walls as well. And then all the internal balustrades and staircases are supported via structural steel elements. So we've got a specific import item, which they call a half-inch channel, which is manufactured in Germany. It's a hot rolled section, and you use that to clip in a type of clip for balustrades. So you can do balustrades as a temporary balustrade in that, and then following with a permanent balustrade, which you can see on the photos that will be uploaded to the website. So some of the challenges we experienced in the Plaatje University project in Kimberley was the accuracy required. So the accuracy required on site for us to be able to install the steel elements were higher than the design specification. So in some instances, there were 1 millimeter accuracy required. For instance, we had a structural wall and we had a structural roof, and those two items are interconnected via a structural beam with a casting item in the wall and a casting item in the roof. Now, the wall was casted almost a year in advance prior to the roof. Now, all those accuracies combined added up to us having to spend more time in the detail. And then also in the design process, we were quite involved with the engineers, which were Oricon, and they basically enabled us, and they gave us 3D renders to be able to install these all these structural elements. Then also there was casting items for balustrades, which is a half-inch channel. It's a hot roll section manufactured in Germany. Then above that, some of our shop drawings were done in 3D, which using AutoCAD and Rivet. And using these two programs or these two software, it enabled us to achieve the accuracy and fulfill the design requirements. Because some of the requirements on design was left to the shop detailer, and that had to be picked up and built to suit as such. A bit of innovation that's on this project is a combination of numerous specialized steel elements. So we have hanging staircases using a detang or similar type of hanging system. You'll actually see a similar product use it currently at OR Tambo International Airport. It's a very similar product. It's a threaded rod that suspends the staircase, and to install these staircases, some of these elements had to be incorporated because there's no other way of doing it except with the steel elements. Then further to the staircases, there's balustrades, there's mesh, there's screens. So all these elements basically serve a dual function. So they'll be architectural, but they'll also have a structural function, and basically seamlining the process using the same element to serve two purposes. That's what makes this project quite unique. When you have a look at the build and at the design and the concept, the whole shell is a monolithic concrete envelope supported via structural steel elements. All the walls want to cantilever to the outside, and if it's not for the structural steel element, they'll basically fall down and there'll be a structural collapse. So this just details the importance of using steel elements to fulfill these shortfall of where as a material as concrete couldn't provide that type of stability. So in my opinion, the Plaatje University project would not be able to be constructed without steel having the same time frame. So using these steel elements also assisted with the time frame and getting the time or the build time quicker. And then on the other side, it provided major structural support, like the lift shafts. They're supporting the slabs, the walls, and providing lateral stiffness to the walls as well. If it weren't for steel elements, a lot of these processes could have been done in another material, but it would have been a lot more complex, bulky, it wouldn't seem seamless. So the structural steel and architectural steel has been so incorporated in the project and in the build that without it, there would be no way to construct it looking like it is. For a very, very simple example, we have facades and shop fronts with steel elements as a subframe, which is then cladded with a glass or aluminium frame, but you can still see the steel element behind the glass. So it's a combination of a few elements, using steel as major structural support and also using steel as an architectural feature or function. What I'm most proud of on this project is that we never had to break a piece of concrete or drill a piece of steel, because everything was manufactured to suit. Proper measurements were taken using a proper total station manufactured by Trimble. And without this 3D design concept and this 3D design integration, a lot of these processes would be a lot harder to do, and also shop drawings were quite dependent on measurement from site. So we gave them the right measurements, and the right elements were engineered or procured. So in some instances, some of the elements had to be changed to suit construction. And I'm quite proud of the way the contract was set up and the way the whole team worked together, as the contractors and the engineers and the architects, and everyone basically having an interest in the project, bringing their bit of expertise, or sometimes a bit more than a bit of expertise to the project, and basically enabling a building to stand 2.4 meters in the air, having no structural support except steel.